Hello everyone. We are going to start our session for today. This is our first. This is our fourth session of Geotechnical Engineering 2, which we are taking during this class. So first of all, I will start with the introduction and providing some of the important guidelines through which we are going through this course. So first of all, my name is Sumit Kumar. I am a PMR of Research Scholar at IIT ISM Dhanbad. I am taking the class of Geotechnical Engineering 2 during this semester for you, which is taught by Professor D.N. Singh sir from IIT Bombay. So over here, I am discussing the concepts as well as some questions which will help you to enhance your concepts and build your concepts from this subject. So I think last week class must be helpful for you. Over here, those who are attending online or either after seeing it on YouTube. So I am thankful for all the audience who have watched my classes, and I think that will contribute in your knowledge base as well. So some of the important instruction before starting the session, I will want to give you that this session will run for 2 hours from 3 to 5, and all the material which is discussed during this session will be uploaded by me on a on a link from which where you get the access. I think you are already got those links where the material get uploaded, and this video is also get recorded for you, and you can access these videos on YouTube anytime. So I will add on extra point for those who are watching on YouTube. So please watch the full video, and at the end the some questions are given for you. That is not the compulsion to solve, but if you solve those problems, that will help you to build the concepts in a better manner, and your answer writing skills also get enhanced. Okay, so first of all, I want to another point over here, like if at some point of time I get disconnected from the call due to any internet connection problem, so be there in a meeting. I will rejoin and take the session from there on as it is going. So first of all, now I will go to start the session. In the initial session, first of all, I will give a small revision of the last session. In the meanwhile, I hope some more people will join, and then I will go with a new content. So this will also help you to found out what we have gone through during the last three sessions. This is a very quick revision, which takes almost 5 to 10 minutes, not more than that. Afterwards, the new content will be discussed over there. Okay, so first of all, I am starting the revision sessions of the last classes. Afterward, I will go ahead with the new contents. I think audio and video will be clear for everyone. So now I am sharing my presentation for you. Okay. So I think so presentation is visible for you. Okay. I as I am seeing it is visible for everyone. So I will go ahead from here and give a quick revision from the last three lectures. Afterward, I will start with a new content. Okay. So first of all, we have started our discussion of the course of geotechnical engineering 2 with the concepts named shear strength. Over there, the shear strength is the most important parameter because it will be useful in all the aspects of geotechnical engineering. When we are talking about the geotechnical engineering too, we have already understood that we are applying the concepts which we have gone through during our geotechnical engineering one course or the soil mechanics course. We both the course named different, but they have the same content which you have gone through. Those applications to the wider aspects we are looking over here. So first of all, we understood the definition of shear strength. After that, on which factor shear strength get different, like cohesion and internal traction, is understood by us with the help of different examples. In the last 2 to 3 classes, we have discussed the several tests, specifically the direct shear test and the vane shear test. Today, we are earlier also we have discussed the triaxial test up to some extent, but in this class, we discussed the triaxial test in a broader aspect because during this week when you go across the week 4 lectures of the NPTEL, you found that The triaxial test is discussed over here, so I will try to cover those concepts and some problems based on that that will help you in understanding the concepts, whichever whatever the gap. And meanwhile, if anyone have some doubt, try to write in the message box. So I will take those questions at the end. Okay. So we have studied the importance. What are the importance? Why we are studying the shear strength? As I said in the starting, only that shear strength is the most important parameter that will help in understanding the behavior of soil. On the basis of that, we can say that this much strength the soil have on this much applied stress the soil get felt. Accordingly, we designed our substructure, hence the superstructure as well. So moving ahead, shear strength in a cohesive soil and shear strength in the cohesionless soil depend on the different parameter. Like in cohesive soil depend on cohesion, while in the cohesionless soil the angle of internal friction become the important parameter. And we have discussed those points like why cohesion is more important over there and why the angle of internal friction. So those points I am not taking in detail because this is the revision sections which I am carrying towards of the last three lectures. So in the first 10 to 15 minutes, afterward, I will start with the new content. So some more points about shear strength. When we talk about the more points which we have gone across in a shear strength, what are those important points we must have to understood? So, the shear strength is a most important parameter. First of all, in during our first class, we have related the principal stress, major principal stress, minor principal stress. We have related the value of shear stress and the normal stress with each other. How we can get the value of the normal stress and shear stress inclined at some other inclination, specifically if we know the stresses in the x and y direction, then how we can get the value of specific normal stress at specific inclination we have understood during our first class. This is the most important concept which I takes some time to describe in the last three classes as well. Today I will also explain you that this is the parent body and this is the detached body. When the body get detached from the parent body, it follows some path, and this is the critical path where the stress is just above the critical stress. That's why the failure takes place from this point. This is the practical example, practical field representation shown to you that will help you to understand those factors that why the patterns fails from these places only. Why not it fails from other places? Because it is the critical combination over here only. The applied stress is more than the critical strength of the soil, critical shear strength of the soil. So those things you must understood because I have discussed this at the several point of time during the last three classes, and this is a basic concept. The concepts of weakest plane also come over there one. So you need to understood those points to get into the subjects. Afterward, we have studied that the stress are applied in the triaxial way, but we study the sigma only two direction. Why this is happening? You could understood like specifically if you see the triaxial test which we are going across today as well. So in the triaxial test, the stress are applied from all the three directions. The two directions stresses are considered to be same, so we relate sigma 1 and sigma 3. Those interrelations are equally important, and we convert the three dimensional to two dimensional considering the plane strain case that will help us to solve the most of the geotechnical problems. And we have given the sum of the relation with the help of to find the shear stress and the normal stress at specific inclinations if we want to get the value. So those interrelations are also developed by us, and on the basis of those we have solved many problems. We have discussed about the Mohr circle, and in the Mohr circles one most of the important slide I will discuss with you to, again for your as division. Other points you I have gone across. You can go through my last videos, specifically first class for these concepts, and there I have discussed in very broader aspects, the broader problems. I have also taken the problems. Those problems are there only in the presentation. If you go across, you can understood those concepts. So what I want to discuss that we have generalized the solution for this, and when we talk about the Mohr circle, some important point we need to understand from where the question gets framed, from either the subject is strength of material or geotechnical engineering. If you have gone through any of the exams problem, you found that there are the many problems have been asked from the when we go across the strength of material or geotechnical engineering, you could see that the problems had been asked regularly on the basis of the Mohr circle, that to find the radius of circle, to find the major and minor principal stress. You, if you know the major and minor principal stress, what is the value of maximum shear stress? So all those aspects are shown over here, and there is interrelation as well. To find the major and minor principal stress is equally important, which is given over here. So we solve the problem on this, and that is present in this presentation, which is already shared with you. So you go across those problems and you will understand the problem. And I also give some of the homework, which is also written in the last of the presentation. So you go across, you will understand those concepts in a very final. So when we talk about the shear strength, what is the application? Application is the most important part. Two important things like significance and application. Whenever we study anything, we have the consideration to understood that whether we are whatever things we are going across, whether it is useful for the design engineers, the practical implementations. So that's need to be understood. So those things has been seen that it has a wide aspects of application in any of the terrain, either it is a plain, mountainous terrain, or any terrain. These concepts are helpful. We have understood that what is the pool, and we have tried to generalize the state of stress with the help of relation of sigma and tau. On the basis of that, we have solved many problems. We have understood the problems, and we have solved the problem with the help of analytical method. Analytical method is nothing but the interrelation between the two perpendicular stress, normal stress direction and the shear stress, to find the value of principal stress. And we also can use the concept of the principal stress to solve those problems as well. We have also understood that how to found the plane which is, that is inclination of shear plane or inclination of principal stress plane. So that we also understood, and you can go across these problems, or and all the contents of the video you will understood very easily. With the help of the Mohr circle approach, we have solved the problems, and afterward we came to the Mohr Coulomb failure criteria. And the Mohr Coulomb failure criteria is basically, we know that the shear strength is the function of stress, that is effective stress in a real term. When we say, we will discuss those things as well, specifically when we talk about the total stress approach and the effective stress approach. We will go across those points that will build your concepts in a very far better manner. When we go across the tri-axis test, we have understood that what is the value of cohesion and what is the value of shear strength and what is the angle of internal frictions. So those aspects will be taken care with in our discussion. The definition of key term is equally important. You should go across those terms. Those terms and definitions may be in some of the important problems when you go for your exams during this course aspects. So, what are the outcomes which we discussed during the session each over there? Now, I will start with some new content. So, I think so. Whoever are we are expecting must have joined, and if not, so I hope that you must go across these videos during on YouTube. So over there you will get those knowledge aspects with you. So I will go ahead with the new concepts and new content for you, which I have developed. So I will start from here only, and go ahead accordingly. Okay. So this is the fourth session. This is the fourth session of the geotechnical engineering two course. Up to this time, we have did our revision of the last three lectures specifically. Now today we are starting with some of the new aspects that will help you to understand the concepts and make you the understanding of the tri-axle test, that how tri-axle test we are going to perform, what are the major aspects we are looking during our tri-axle test, and how we can uh, how we can perform the test, how we can control the test, and what are the aspects taken care of, specifically talking about the pore water pressure parameter, and what are the different advantage we are getting using these tests, how it will implicate the real field conditions. So those aspects we are going across, and I think you will enjoy this session. If you are over here with me as well, if not, if you are going across the video afterwards as well. So this is the important point I want to add. Please go across the video. You will found it very helpful. Okay. So first of all, we start with exploring the triaxial testing in geotechnical engineering. As I have already said, today we mainly focus on the triaxial testing. We discuss all the aspects. So first of all, we start with the definition of shear strength. Why we start with the definition of shear strength? Because whatever we are doing over here to get the value of the shear strength, and that what is the value of shear strength is the one of the important aspects for which we are performing this test. So, so shear strength is a material response. When we talk about the shear strength, it is a most important factor in the geotechnical engineering. If someone is from the structural background and he think that we talk about strength, so he said like characteristic compressive strength. But when we talk about the shear strength, it is mostly related to the geotechnical aspects, like the soil engineering. So this concept is most significant, and when we talk about the concept of weakest plane, the weakest plane is that plane from which the failure takes place. From there, the soil cut down and flow ahead, and that critical plane, that plane over there, the stress applied is more than the shear strength at that section will lead to the breakdown of the soil from there. So that is the weakest plane concepts. And what are the factors? Some of the major factors like earthquakes. We have gone across these concepts earlier as well. That the earthquake and earthquake is one of the important factor. Apart from that, if the fault is there, that is also act as a factor. And the other factors like the slope instability, construction activity can also lead to the failure of the soil surface in theory. Moving ahead, why we are talking about that? What it must have application and significance. During our revision section, we already discussed like important and significance is the one of the most important aspects which we need to take care of, because anything we are going across, we are doing for some of its applications. We are developing our knowledge in any aspects to perform it, to use those aspects to if I have already said like anything we are reading, like any novel you are going across, so you need to develop your might be personality development, or those novel might also give you understanding of the English literature you might be interested in, so you could write some your own aspects. So anything you are studying, try to implicate, so that must have some significance and that must have application either in the if you talk about the field of engineering, we apply in the field of engineering to develop, to design some of the infrastructure. If you are if I am talking about some of the storybook, so from there you get some knowledge that will implement in your life and you will become some better person. You will get a good personality while interacting with others. You will become a good person. So the application and significance, whenever we are talking about anything, the application and significance is one of the most important aspects. Okay, so talking about the engineering significance of understanding shear strength in the geotechnical projects, we are well aware about that in retaining wall, in slopes. These aspects are very useful. The role of shear strength is most important in accessing the stability of natural and man-made structure. This need to be understood by you, because any natural structure is there over there. If we are studying, so we need to understood that. the value of should be the value of shear strength. So we could sustain that this much load should be applied after applying the factor of safety. Okay. Moving ahead, we talk about the Mohr-Coulomb failure criteria. The Mohr-Coulomb failure criteria, like the soil failed, the shear stress at the failure plane defines the shear strength of the soil. Basically, during my first class, if you are there, I have explained the concept like suppose soil has a shear strength of 30 kilo pascal. This is example only, or by default you take 30 units. So up to the load 29.9 units, the load doesn't fail. On 30 units also, soil on the verge of failure, but after increasing this value from 30 to 30.01, the soil gets fails. So that is the critical section from where the soil gets failed. So we should be aware about those sections. So how Mohr Coulomb failure envelope get developed is also discussed by us during this session. And there is another concept of stress path like PQ curve. That aspects we are not going to discuss today, but in the coming classes I will explain you the what is meant by stress path and how it follows. So you will understood those aspects up to extent, and that will be quite helpful. But today we are discussing the Mohr Coulomb failure envelope as well during our tri-excel test. So earlier I will discuss those aspects during the tri-excel test. You will understood that how to find those points. Okay. So some more point about the Mohr-Coulomb failure criteria is like to development of the Mohr-Coulomb failure envelope, and it is the one of the important aspects. If we able to form the Mohr-Coulomb failure envelope, we can explicitly see that over there the soil get filled, and at this point the our structure will be safe. So those aspects you need to understood. I will discuss those points that when the soil get filled and when it will be safe from the failure. So here the Mohr Coulomb failure curve is shown. In a subsequent slide, it is explained very broadly. Over here, first of all, I give you the broader picture, then we go in the micro confinement of this concept. So first of all, we applied a sigma 3 value. I will come at this curve again if needed. If any one of you have any doubt after studying the tri-excel test, I will explain you again. But at this point of time, I want to explain you like we already discussed during our second session. Over there, we discussed a relation between the sigma 1 and sigma 3. That is sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, or for tan square 45 plus 5 by 2 we also write a relation in the term of sine. So you must be aware, you are aware about these concepts. You, because I know that I have taught those concepts during my second session in a small aspect, but I have discussed. So over there, with the sigma 3 is the confining pressure. So first of all, we apply a value of sigma 3 on the basis, after applying the value of sigma 3, whatever the test we are performing, either UU, CU or CD, like unconfined, unconsolidated, confined, consolidated drain and consolidated and drain. Whatever test we are performing, during each test we apply a stress, and on the basis of that we apply the value of sigma 3. After that we apply the axial stress, like that is the deviatric stress. On the basis of that the deviatric stress is sigma 1 minus sigma 3. On the basis of that we will able to find the value of sigma 1. And so first of all we got the value of sigma 3, we got the value of sigma 1, so we form a Mohr circle on the basis of value of sigma 1 sigma 3, that is the one first circle. After that we vary the value of sigma 3. Suppose earlier we take the value of sigma 3 as 20, afterward we take the value of sigma 3 as 22, and on the basis of that we form a circle. After that we take the value of sigma 3 as 25, we again got some value of sigma 1. On the basis of that another circle gets formed. Subsequently we form the circle, and after drawing a common tangent to those circle, there is a straight line get formed, and that is only the Mohr Coulomb failure envelope, and below which any stress is there, or up to that stress soil is safe and it doesn't get failed in shear, while if the stress get increased from that point, the soil get filled at those sections. I think the point will be clear. And here the another representation of that only is shown for you. Over there you can see that first of all sigma 3 dash we one sigma 3 dash 1 is known to you. For that sigma 1 has been found. Afterwards, what I am telling, we have applied the sigma 3 dash 2, and for that we form the sigma 2 dash, and subsequently we go ahead and we are able to form the Mohr Coulomb failure envelope, so that we are able to get the value of Mohr Coulomb failure envelope. So this is the point I want to make. I think these points will be clear for you. Okay. So I am going ahead in sections. So whatever I want to talk about more Coulomb failure criteria. So the stress condition for in another soil, eh, a sample is represented by the Mohawk circle that lies below the failure envelope. What I am discussing, the every plane within the sample experiences a shear stress which is smaller than the shear strength of the soil, so soil doesn't get failed. But if the stress get increased from that point, the soil gets failed. So that is understood by you. That is a very basic aspect. Now we go with the triaxial test, and for the triaxial test, what are the aspects we are looking at? We will go with that. How we perform the triaxial test, what is the procedure, and other points we will go from here. And I think that will help you to develop the understanding of those points. Okay, over here I will go ahead. I am over there for looking at. Okay. So what we mean by the triaxial test, we want to understand that what are the triaxial test, what are the apparatus we are using, and how we are performing the triaxial test with the help of different aspects which is known to us. We will looking over here on those aspects. Okay. So triaxial test is a 3D dissipation of stress on a material. It offers a better replication of in situ stress condition, help in understanding the soil behavior under the more complex loading conditions. And moving ahead, the triaxial test, how the triaxial test is carried out, what are the apparatus conditions. I have shown a schematic diagram as well as some other pictorial representation for the triaxial test for you. So that will help you to understand those aspects. So triaxial test is carried out in a cell of cylindrical soil sample having a length to diameter ratio of 2, and the usual size are 76 mm into 38 mm and 100 mm into 50 mm. Three principal stresses are applied to the soil, out of which two are applied water pressure inside the confining cells and are always equal. You should understand this point, like the confining pressure may be applied by the different means of liquids, but we usually use water for that only. And the third principal stress applied by the loading ram through the top of the cell and is the different to the other two principal stresses. The a typical triaxial cell you can see over here. In this cell, the how the deviating stress is applied and how the pore water pressures and the different cells are represented. There is another schematic diagram is also there in a coming slides. Over there, you can also found these aspects. So moving ahead, the when we talk about the test procedure for this, the soil samples is placed inside a rubber membrane which is sealed on top cap and bottom pedestal by the rubber rings. For test with pore pressure measurement, the porous discs are placed at the bottom and sometimes at the top for the specimen. Filter papers, drains may be provided around the outside of the specimen in order to speed up the consolidation process. The pore pressure generated inside the specimen during the testing can be measured by the means of pressure transducers. And when we talk about some other aspects of triaxial testing, it is one of the fundamental and the most powerful technique in the geotechnical engineering, in which the understanding of soil behavior is found for the greater extent, and we are able to find the value of the shear strength parameters like C and phi. So over there during these presentations, and the triaxial testing setups will be shown to you. How we are able to perform the different type of triaxial test will also be implemented, that will help you to understand the concepts, and what will be its setups and the type of tests are also presented to you, and the significance of parameter analysis will be understood by you over there. With the help of that, what are the parameters we are able to find will be seen by you. So moving ahead, the triaxial compression test consists of two stages. The first stage is the soil sample is set in a triaxial test where confining pressure is applied. When we talk about the confining pressure means like what are the pressures we are applying in order to develop the stress, in order to develop the to get the value of sigma 3. So that's what we are doing, we are going across. Give me a minute, I will come in a 1 minute time. मेरा मीटिंग ज्वाइन करना, मेरा मीटिंग ज्वाइन मीटिंग ज्वाइन करो, देखो आवाज आ रहा है, चेक करो। Okay, so I am here again. So let's start back again. There is some of the network issue there, so that's why I want to check those setups because the network is fluctuating at this point of time. I think so audio and video will be clear. I think so. And if any issue is there, you can communicate with me, and that will be fine. Okay, so I am going ahead with my discussion. Like the triaxial compression test consists of two stages. The It consists of two stages, and the first is it consists of two stages, and we have discussed about the first stage, that what is happening in the first stage. When we talk about the second stage, uh, in this stage additional axial stress, also called the deviatic stress, is applied, which include the shear stress, which include the value of shear stress. And in this case, the axial stress is continuously increased until the sample gets filled, and during both the stages the applied stress, axial strain and the pore water pressure, or the change in the sample can be measured, with the help of which we are able to find the value of sigma 3. And during the value of second stage, the during the second stage, the value of we can able to find the value of deviatic stress. With the help of that, we are able to see as it is discussed, and it will be discussed again over here. Like we are able to get the value of sigma 1 minus sigma 3 as the deviatic stress, and on the basis of that, the value of sigma 1 and sigma 3 is known, and on so we are able to form the Mohr failure envelope. In a similar way, if we know the value of sigma and 1 and sigma 3, and if we know the soil type either is cohesive soil, so we can consider the value of phi as 0, so we could get the shear strength parameter like C and phi, and converse is also applicable for the cohesionless soil. So that point will be very clear. I think so. Here the representation is also shown for you, in which you can see that during the stage 1, the all-round pressure is applied, that will be equal, like sigma 3, that is said to be confining pressure, while in the stage 2, this, what is the shearing stage, the another axial stress is applied, and on the basis of that, what is the value of the deviating stress we applied, on which the soil gets filled, is found by us, and on the basis of that we are able to interrelate the value of sigma 1 and sigma 3, and ultimately we could state that the what will be the value of shear strength parameters during our study. So this thing will be very clear, I think so. And when we go ahead during this concept in broader aspects, we see apparatus for that. What we have seen in some small aspects in the previous slides. Over here, you can see a triaxial test setup in a what is the O-rings, what is the impression membrane. There is a membrane in which the soil is first of all kept. We could control the drainage condition during the triaxial test in a different test like UU test. There is a no water is allowed to dissipate. The volume change remains zero. Similarly, when we talk about some other tests, the like CU test and CD test, the drainage condition during the first and the second stage will be different. So that could be only controlled if we have this type of setup where we can control the or measure the pore water pressure. So we could able to get the effective stress parameter as well as the total stress parameter wherever it is required. Like for in UU test, and the soil like clay soil will be tested, because in clay soil the water is not allowed to flow down during any stage, because in clay we know that the pores are very small, so the to dissipate the whole water will take a huge time. So these things will be clear for you in my opinion. So I will go ahead. So when we go ahead, we are going to understand the tri-excel testing. So what is the purpose? Purpose will be some or more or less will be clear for you. But I will add some points in for the audience over here, and for all the other audience who are going to watch this on the platforms like YouTube. So I will try to add some more points. So first of all, understanding the triaxial testing. The purpose is to evaluate the shear strength parameter of the soil. The basic purpose is that only, and that's why we are conducting the triaxial test. We also able to get the value of consolidations, but that is the another aspects that will also be taken if required. So the first of all, we collect the sample and extract the cylindrical sample from the field. So we could put it into the membrane, and afterward we will apply the different conditions for water, and to if we are if we want to measure the pore water pressure, specifically we will go test by test. There we you can understood those points as well. And the setup is a sample mounted on the porous stone sandwich between the loading and the base plates. So first of all, the types of triaxial test. There are the these are the types of triaxial test. The specifically three is U test, unconsolidated undrained test, U test consolidated undrained test, and CD test consolidated drained test. So these are the four tests. If you talk about UU test over there, the drainage water is not allowed to flow down, while in consolidated undrained test during the first stage water is allowed to flow out. So during the stage one, like the confining stage, the value of sigma pore water pressure will be zero, while in the second stage the pore water get developed because the water is not allowed to flow out. Similarly, the case for consolidated drain test. Another test is the UCS test. So in the UCS test, we perform the unconfined compression strength, and we also know that from the basics only, like UCS by 2 is the cohesion, and with the help, if we able to get the value of UCS of undisturbed sample, we are also able to get the value of sensitivity. So this is also one of the tests which we are performing in day-to-day basis. Over there, the confining stage is not important. The second stage is only important because that stage doesn't come into picture. So first of all, we go one by one for the first of three tests and take the sum of the brief aspects of those tests. So first of all is the UU test. And in this test, the cell pressure is applied without allowing the drainage, then keeping the cell pressure constant and keeping the cell pressure constant, and the diabatic stress is increased to failure without drainage. While in CU test, what I have told during representing the last slide will be written here, but I will read that for you for a better understanding and maybe some point more clear point you will understood. So in this drainage CU test, the drainage is allowed during the cell pressure application. Then, without allowing the further drainage, the debuting stress is increased, keeping the cell pressure constant. This means that during the second stage, water is not allowed to flow out. That is the meaning which could be understood, which is the real meaning over it. When we talk about the CD test, so this is the similar to CU test, except the debuting stress is increased. Drainage is permitted during the second stage as well and during the first stage. So the rate of loading must be slow enough to ensure that no excess pore water pressure develop. If the rate of loading will be fast, so we know that if the stress is applied instantaneously, it will reflect as a poor water pressure. So we don't want such cases during this test. So the application of loading must be slow to ensure those problem like to not the excess poor water pressure not get developed. Going ahead, the pore water pressure measurement is one of the important criteria because we know that this is one, and I think so one of the most best advantage of the triaxial test, like we are able to find the pore water pressure parameter, pore water pressure measurement, which is not we are not able to found during the vein shear test, direct shear test, and many more tests which we are performing. The majorly we are using these tests only, but in other tests as well, the pore water pressure measurement is a trivial work for the geotechnical engineers. So measurement of setup, the value used to apply the back pressure or the measure the pore pressure. And when you talk about the influences test types, the impact the consolidated undrained and unconsolidated undrained test. This is done by this. Now we talk about the analysis and parameter. What are the parameter we are looking at? During the performing of the triaxial test, we are most concerned about getting the value of the cohesion and angle of internal frictions. So when we talk about the test approaches, the triaxial test offers the comprehensive insights into the soil behavior. Basically, with the help of this test, we could state the behavior of soil. And when we talk about the design implementations, the derived parameter is crucial for geotechnical designs as well. Moving ahead, when we talk about the what are the significance in the triaxial test, so it is act as a brahmastra of a geotechnical engineering in itself, because it is a one of the vital and irreplaceable techniques. The many more techniques might be developed by the geotechnical experts maybe in future, but it will be irreplaceable because whatever the value, whatever the result it will give is a most important and vital results that will add value to the geotechnical aspects of the soil while calculating the shear strength. And it also provides a view of soil property under the various conditions, because we could control the drainage conditions. So during the different conditions of how the same soil could behave, because it is not compulsory like we have to perform this test on the specific type of soil, but on the same soil we could perform this test, and we could get better aspects about the value which we are getting by performing the same test on different test on the same soil. So we will state its properties as well, and the material characterization is one of the most important aspects we came out with the help of triaxial testing. Moving ahead, so adding some of stating some of the more significant point which will be provided by this test is like the first stage simulates in the laboratory in situ condition. As I have stated earlier as well, like if you take a soil cylindrical sections from the bottom of the soil, you found that the stress from the two direction is almost same, and the third direction stress will be different. So it will implicate the real field conditions. So it will be quite helpful for us. And consolidation will occur if the pore water pressure which develop upon the application of confining pressure is allowed to dissipate, and otherwise the effective stress of the soil is a confining pressure or the total stress minus the pore water pressure which exert in the soil pressure. So during the effective stress and the total stress and pore water stress study, you understood these aspects during the geotechnical engineering one courses. So the magnitude of shear stress acting on the different plane could be calculated. That is well known to us from our first lecture only. So I will recap the section which we have covered up to it. Afterward, I will move ahead. So up to this point, we have understood that the triaxial testing stands a con- uh, concrete in geotechnical engineering. It is irreplaceable and offer a profound insights into the shear strength parameter of soil like C and phi. And by doing this test, the triaxial doing this different type of triaxial test, incorporating the pore water pressure measurement, so we engineers could understand the soil behavior property and the material characteristics of soil as well up to a extent. And triaxial testing remain a timeless and essential tools continues to shape the field of geotechnical engineering up to a very long time. Many more tests may be get developed, but this test remain irreplaceable. Moving ahead, now I will add the point related to advanced insights into geotechnical engineering with the help of triaxial testing techniques. So over here, uh, first of all, the triaxial testing has evolved significantly over the time. The transitioning from traditional method involving the mercury columns to the modern electronic systems are taken place of those systems. In this presentation, a complexity of triaxial testing includes the sample preparations, corrections, and the drainage considerations are taken. So you will understand those points over. Earlier we are using those, so this is not significant as of now. So modern techniques, different electronics pressure sensors get developed with the help of which we are calculating the value. So that is not much significant. That's just for sake of some points which remain with you during for your understanding. I have kept in the slides, so you can go across that. But that is not aspects which is so much important at this point of time. Now we will start our understanding with the help of test setup components. So as we earlier know, with the help of the aspect like the first of all the sigma 3 or the confining pressure is applied with the help of water. And when we talk about the load frame, a motor controlled frame for the uniform shear rate is used, and a plunger and a proving ring is allowed to apply the axial stress to transfer the load to the sample and measure the applied stress. The porous stones ensure the controlled drainage condition in the soil, and some more sample collection technique is used to collect the cylindrical soil sample extracted from the field. The sample length, there is a ratio of L by D, typically the twice the diameter for the actual testing. Whatever the dia of cylinder we are taking, the length of sample should be twice the diameter for our true result, to get our more accurate result. When we talk about some other setup component like mounted on a porous stone enclosed by rubber membrane, and it will kept in rubber membrane up, on which the water pressure is applied. That is the sigma 3. When we talk about loading, the loading plates applies the axial stress via the steel plate and the probing ring, and that is nothing but the dielectric stress. And lastly, the deformation measurement takes place where the dial gauge tracks and volumetric. deformation is measured. Some of the correlations corrections factors are also used, like the rubber membrane correction. The rubber membrane affect the sample strength and deformation. So there is a need of correction for that, and the shear strength correction is also there in due to the correction of the higher axial strength due to the membrane, and the axial strain correction is also one of the aspects, like the compensating for the axial strain causing by composite sample. Now, advanced correction method like the radial drainage consideration help in simulating the three-dimensional consolidation with the radial drainage, because it implicit the three-dimensional condition which is going actually to take place in the field. The method which is used is the wrap filter paper with the silt around the sample enabling the radial drainage. When we talk about the some more aspects like the incorporating the time factors, so a selection of the strain rate is based on the base of time factor, and when we after this we take a recap of the these sections. Over there we study the some concepts. So the triaxial testing has transformed from mercury-based method to advanced electronics technique. In this section, we have gone across what are the advancements we found specifically in this test only, from our traditional techniques to the modern techniques to the different corrections factors we have understood for the rubber membrane shear strength and the axial strength, that is will also very crucial for us. When we talk about some more point, the radial drainage simulation and TOEF calculation further refine the testing process, and compression understanding of the interfaces induce the higher quality and reliable triaxial test outcomes. Moving ahead, we will study the some of the unveiling interaction of the consolidation drainage triaxial testing for our analysis. But over here, I will take a small break of 5 minutes. We will start at 4:05. Uh, please wait up to that time. Welcome back. Now we will again start our discussion from here. I think everything will be clear to you. If anytime anyone have any issue, you can write in the text box. If related to audio and video, some problem is there, you can tell me anytime. Okay. So first of all, we are in understanding some of the more aspects about the triaxial test, like the consolidation trend triaxial testing. So triaxial testing uh, is in a geotechnical engineering allowing the evaluations of the soil property under the various loading conditions like drainage conditions, different drainage conditions. So in this presentation, we are discussing the complexity of the consolidated drain test. In this section specifically, I want to access. Otherwise, we are discussing about all the UU tests, CU test, and CD test aspects of the drainage condition, consolidations characteristics, as well as the upper and the lower bound theory as well. So in the membrane property correlation, the property of membrane, the membranes are elastically, the membrane which we are talking about in which the soils are kept and to apply the pressure, and the correction process are also performed for the value of the shear strength, for the unit of the membranes. So those aspects are also there, and the elasticity, the membrane introduced elasticity, add-on elasticity influencing the value of strain and the shear strength is one of the aspects which the civil engineer should need to be taken care of. We simulate the 3D conditions with the help of radial drainage. The last last slides, you have seen a word radial drainage. So Basically, it will over there. It will also state that it will implicate the real field conditions, which is going to take place with the help of this radial drainage property. So radial drainage simulates the three-dimensional consolidations. The methods which will used over here is the filter paper with the slits enhances the sample, enabling the radial waterproof percolations, and the enhanced consolidations. Basically, it will enhance the consolidation process, shorten the drainage path, accelerates the consolidation process. Moving ahead, the consolidation characteristics, the CD test philosophy, understanding the material behavior with the no remaining volumetric moisture, the initial state, the hydrostatic conditions, sigma 3 pressure, and the no shear stress is there. When we talk about the time dependent behavior, the volumetric deformation changes with time due to consolidations, CV value determinations, the value CV is over here is the coefficient of consolidations that is obtained from the time to constant volume rate, and what are the other aspects benefits of the consolidated trend test is like to the get the accurate value of coefficient of consolidation under all round pressure. It is unlike the one dimensional state, so it will represent the real value of coefficient of consolidation, so we get the better idea about the consolidation settlement in a field. Another important points from the loading condition is this process is extremely slow shearing, so drained condition due to the poor water pressure dissipations. And when we talk about the embankment, the gradual poor water pressure dissipations during the embankment construction. As we know, the construction of embankment takes place very long time, so the gradual pore water dissipation takes place during its construction time as well. And when we talk about the strength variations, the upper bound of material strength is obtained with the help of CD test. Basically, upper bound we mean the maximum strength that specific section can take place would be found with the help of CD test, because in this case the water is allowed to flow out in both the stages, like the confining stage as well as the sealing stage. So these points are clear. Now the upper and lower bound in geotechnical engineering perspective, when we talk about these theories, basically you must have uh, known about the term from the still, if you have gone through the courses of still structure, the upper and lower bound theory, equilibrium, sway mechanism, and different mechanism you have understood, have gone through during the plastic analysis study. See, when you talk about geotechnical engineering practice, it is about the material strength. And when we talk about the ultimate strength, the CD test provide that upper bound strength. Basically, the ultimate strength which soil can sustain in any condition. And when we talk about the significance, we get the critical in limit equilibrium and plasticity theory study. So again, we recap these sections for you. I recap this section for you, like the consolidated drain triaxial testing provide a valuable insight into the soil behavior, accounting for membrane effects, radial drainage, consolidation characteristics, and the strength bonds. Understanding these entrances enhances the geotechnical analysis and design, contributing to the safer and more efficient engineering solutions for the field engineers. And now we go ahead with the next section in which we explore and get develop the understanding of the unconsolidated, untrained, consolidated, trend, and consolidated untrained tri-excel test in the geotechnical analysis. So first of all, the total stress parameter we talk about. After that, we talk about the effective stress parameter. When we talk about the total stress parameter, when the UU test is performed, like on if you suppose it's clay, so in that case the value of sigma 3 and sigma 1 is plotted for finding the Mohr failure in Vela. Afterward, on changing the value of sigma 3, again sigma 1 is found, and that value is also given the radius of Mohr circle as same. Hence, the circle get plotted in a similar manner. Similarly, test 3 also give the same result. When we draw the tangent, it will give the value of cohesion. So in UU test it implicates the real field clay conditions. So the cohesion is known and the angle of internal friction is zero. Similarly, when we perform any other test like CU and CD test, the what are the output we are getting will be shown over here with the help of diagrams. So the all Mohr circle for the UU test plotted in term of total stress. This must need to be understood in the term of total stress, not in the term of effective stress. When we go for the effective stress, you come to know that the results are implementing the same value for all the cases whatever we are able to perform over there. Okay, so the failure envelope is a horizontal straight line as it is shown from the picture. So the value of phi uu is 0. And this can also represented with the help of equations. We also plot the value of sigma 1 minus sigma 3 versus strain in a coming slides. When we perform the CU and CD test, over there we must get some of the value of cohesion as well as phi. And for that, as I have shown earlier, very early in the showing the Mohr failure envelope, it has been shown that by getting the one value of sigma 3 we get the another value of sigma 1, and by changing the value of sigma 3 sigma 1 gets changed, and while drawing a common tangent we find a curve, and the curve when where it intersects the toe axis is the value of cohesion, and the inclination it made with the sigma axis is the value of coefficient of internal frictions, so that will be found. For the test involving in the drainage in the first stage when the Mohr circle are plotted in terms of total stress, the diameter increases with the confining pressure as it has been shown in the previous images. The resulting failure envelope is inclined line with the intercept on the vertical axis, and it is also observed that the CU is not is equal to CCD, means the cohesion during the CU test and CD test is not same, and similarly the value of angle internal frictions is also behave similarly. Why this is happening, that will be understood when we study the effective stress parameter. Over there the value of cohesion and phi doesn't get varied, because this will take place due to the pore water pressure differences, and it can be stated that for the identical soil sample tested under the different triaxial condition like UUCU and CD test, the failure envelope is not unique. But when we go for the effective stress analysis, the curve get formed will be must be unique. Over here you we come across the effective stress parameter. If some triaxial test results of UU, CU and CD test are plotted in terms of effective stress, making into the consideration of the measure of pore water pressure, it is observed that all the Mohr circles at the failure are tangent to the same failure envelope, indicating the shear strength is unique function of the effective stress on a failure envelope. So over here you could see that while accessing any of the test, the failure envelope must be unique, because over there, so it is clearly understood that the problem over there is one and only due to the value of the poor water pressure, the value of poor water pressure due to the different drainage condition during the different test, because we are considering the total stress, not the effective stress. So moving ahead, the failure envelope is the shear strength envelope, which may then be written as tau f equal to c dash plus sigma dash tan phi, where c dash is the cohesion and phi dash is the angle of resistance in terms of effective stress. If sigma n dash is the effective stress acting on the rupture plane at the failure, the tau n is the shear stress on the same plane, and therefore the shear strength, because we know that we could able to find the value of shear strength with the interrelation tau f equal to c dash plus sigma dash tan phi. If on the Mohr envelope as well, we could able to find the cohesion and the value of internal friction, we could state the value of the shear strength of the respective soil. So this point will be very clear for you. Now the interrelation which I am talking about earlier as well is given between the sigma 1 and sigma 3. One of this relation, another interrelation is sigma 1 equal to sigma 3. Tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. because you know that 1 plus sin phi by 1 minus sin phi is written as tan square 45 plus phi by 2. Similarly, if 1 minus sin phi by 1 plus sin phi, which is the k, also written as cot square 45 plus phi by 2. So these aspects, these trigonometry concepts should be clear for you. You could derive those interrelation, or may be you may derive, and you must remember those interrelations, specifically talking about the aspects of the geotechnical engineering. These interrelations many times when we go ahead with this subject. So first of all, the triaxial testing methods such as the consolidated drain and the consolidated undrained test offer the valuable insight into the soil behavior under the different loading and drainage conditions. In this presentation, the principal applications and significance of this test has been shown for you, assigning the geotechnical stability, because stability is the one of the important aspects which we civil engineers are looking for. So now we talk about the effective stress analysis. In effective stress analysis, the pore water pressure. When we talk about the effective stress analysis, the pore water pressure get dissipated, drained condition resulting to zero pore water pressure during the consolidation, and the slow shearing and the effective stress parameter. Effective stress is the parameter applicable to effective stress condition. Talking about the Mohr Coulomb failure envelope, the effective Mohr Coulomb envelope superimposes on the conventional envelope due to zero pore water pressure development, because the variation in the failure envelope for the different parts is only due to the variation in the pore water pressure. If the pore water pressure doesn't get developed, the drainage condition is so sharp. So in that case, the total stress becomes the effective stress. So the curve must be overlapped to each other. Now, we will discuss the sum of the application of consolidated drain test. After that the second test significance and application is also stated. So, stability analysis. Ideally, for accessing the long-term stability of structure like dam constructed for extended period, over there the CD test is performed, like and the seepage and stability study also uses the CD test for the analysis. It is one of the application, the CD test, in analyzing the downstream dam slopes affected by seepage forces and pore water pressure changes. When we talk about the application of consolidated undrained test, the rapid loading, the CU test simulates the rapid loading conditions such as the earthquake or fast construction. So these tests simulate those conditions, while unconsolidated behavior is also the study of the response in cases where the consolidation does not occur within the material's lifetime. So these are some of the important aspects. When we talk about the practical field study, the real life example. So in real life scenario, the foundation construction in the context of rapid building erection and consolidation time is the initial consolidation time due to self-weight rapid construction minimizes the consolidation because it will take less time, so it will not allow the settlement to take place. It will not allow that much time to consolidation to take place on the respective field. Now again, I will recap these sections for you. Like CDNCU triaxial test offer the powerful tool for understanding the soil behavior under different loading and draining conditions by providing effective stress parameter, the accessing the stability in various scenarios. These tests contribute to the safer and more accurate geotechnical engineering practices. Moving ahead, now we will understand the CUUU triaxial test for geotechnical analysis. So first of all, again this section we understood the some of the basic aspects before going into the more detail. So you will develop the understanding about the fact that the triaxial testing includes the consolidated undrained CU and unconsolidated undrained you test offer valuable insight into the soil behavior. Okay, no problem. I think so. Under and it is under the different loading condition. In this presentation, the principal application and significance of these tests for accessing the geotechnical stability will be discussed. So it will be become clear for you from now. Okay. Now shearing in CU test. So we talk about the shearing in CU test. So what would be the condition? The CU test simulates the real world scenario where the consolidation has occurred but rapid loading takes place. Okay, I think. Okay, no. Okay, okay. There is not network problem. It will. The deviating stress, the application of the deviating stress helps to induce shearing after consolidation. The effective stress analysis, the effective stress parameter such as shear strength and deviating stress play a crucial role in CU testing. When we talk about the significance of parameter, the parameter introduction like the parameter represent the efficiency of pore water pressure development for a given sigma 3. While for application of a confining pressure, what will be the pore water pressure developed when the specific drainage condition is taken during a triaxial test, and a relationship with the pore water pressure is determined by multiplying the A and B, and A and B are the Skempton parameter you must understood, which we have discussed during our second class for water pressure measurement, where we have discussed the Skempton parameter A and B, where B is the value of change in pore water pressure parameter. It is the ratio between pore water pressure changes and the value of change in the value of sigma 1, change in the value of confining stresses delta sigma 3. When we talk about the effective stress calculation, a parameter help in calculating the effective stress component as sigma 1 and sigma 3 dash during the testing. Now the parameter obtained from the CU test is the cohesion and angle of internal friction, and the parameter acquired from CU test is the cohesion and angle of internal friction. Excuse me. Okay. Effective effect of Mohr circle. Earlier we have also studied, we have started our discussion with the Mohr circle. We have stated the significance of Mohr circle. We have stated what is the value of major and minor principal stress of the Mohr, how we could get the value of major and minor principal stress on the Mohr circle. So we will go into that. Up to now, we have understood the deviating state, we have understood the confining state, we have understood the shearing stage and how we calculate the value of sigma 1 and sigma 3. And with the help of that, how we can relate the value of cohesion and angle of internal friction with each other is also shown to you. Okay. And so during the CU test, the Mohr circle shift left due to the poor water pressures, reflecting the effective stress envelope and a possible negative UD under the certain conditions. UD might be negative, causing the Mohr circle to shift right. Specifically, we know that if the poor water pressure is negative, the effective stress become more, and if the pore water pressure is positive, effective stress get reduced. So the variation of shifting of Mohr circle takes place accordingly. So the role, when you talk about the role in geotechnical engineering, the basic role is to understand the pre-consolidation pressure, add into accessing the soil strength and behavior. Now we again summarize these sections before going ahead. So CU and UU triaxial test provide a valuable insight into the soil behavior under different loading conditions. By studying the response to shear and pore water pressure, engineer can make informed discussions about stability and design parameter. contributing to the safer and more effective geotechnical practices. So these tests provide those insights for the civil engineers who are working over there to understand those aspects. Okay. Now we move to the pre-consolidation pressure and the shear strength behavior in the geotechnical analysis. So these terms might look that what are these terms, but when you go into the detail of those terms, you found that these are the basic aspects one need to understand before going ahead. Excuse me, I will take some water, then I will again start speaking. Okay. So we are talking about the pre-consolidation, pressure and the shear strength behavior in the geotechnical analysis. So in this study, what we are going across is must need to be understood. Basically, this is the one of the aspects which is which is discussed broadly, but some of the confusion get arrived about the how the settlement takes place and how these pre-consolidation pressures work. So the concept of pre-consolidation pressure and its impact on the soil behavior plays one of the most vital role in understanding the shear strength variations. In a real term, this phenomena of the pre-consolidation pressure and its relationship to shear strength envelope is needed to be explored up to that extent. So one can understood these concepts in a vital way. So first of all, we start with definition and significance. Then we go ahead. So first of all, the pre-consolidation pressure is the maximum historical pressure a soil is experienced before the current state. Specifically, you must go across the pre-consolidation ratio. So, what is the pre-consolidation ratio? Specifically, stress significantly experience in a past to the stress in the present. That ratio is known as the pre-consolidation ratio. So, if a specific soil has been sustained a certain amount of pressure in the past, afterward we applied a stress below which it will able to sustain. Similarly, in the influence of soil behavior is was also one of the aspects that takes a play an important role over here. So the pre-consolidation pressure affects how soil is respond to loading and unloading, leading to the various pore water pressure conditions. And these different conditions will give us the different aspects about the soil and its behavior. Behavior in a real time. The variation in pore water pressure may be positive, may be negative. As the when we talk about the positive pore water pressure, soil with the pre-consolidation pressure less than the current stress exit a positive pore water pressure. It will be very simply understood that suppose a soil over there the pressure which is applied presently is less than the pre-consolidation pressure over there. So whatever the pool water pressure is shown in our pitot tube is the nothing but the positive pore water pressure. Similarly, if we talk about the negative pore water pressure, when the current stress is less than the pre-consolidation pressure, soil exit this type of pressure. Moving ahead, when we move ahead, we found that the pre-consolidation pressure classification. So we talk about the normal consolidated, over consolidated, and a transition zone. So we must need to understood that the what is do we mean by the normally consolidated soil, what is meant by over consolidated soil, and when we say that it is in the transition zone. So, if we talk about the positive pore water pressure due to pre-consolidation exhibit the frictional behavior. Hence, the value of y will be 0, but the value of cohesion must be 0 if it is showing completely frictional behavior like the cohesionless soil. So, that soil is said to be NC, that is the normally consolidated. While, on the other hand, if we are taking the aspects of the over-consolidated soil with the negative pore water pressure due to pre-consolidated exhibit the cohesive behavior. Hence, in these cases, C equal to 0 and phi is not equal to 0. While when we take a condition between these two states, so we must be aware about the transition zone. It is a zone between the NC and OC. The behavior represents an average of both conditions. So over there, the cohesion is also seen and the value of angle of internal friction could also be found. So some of the interrelations showing the value of deviatric stress with the axial strength. So over there you can see that for a dense sand, there is a peak is found at some deviatric stress value. Afterwards, it will go fall for the small stress. The strain get increased. Similarly, if we talk about the loose sand, there is a no clear failure section has been shown, but for this aspect as well, we could consider up to after this percent of strength, the soil, specifically loose soil, loose sand, is considered to be failed. So those aspects have been developed by the geotechnical experts for our understanding. When we try to understand the plots which is representing the variation of axial strain with the volume changes in the sample, the compression and expansions. So you can see that the value of you can see that the value of uh, the value of the I think I'm audible. Oh, sorry, I got muted for a minute. Sorry. I will again state those terms for you. So you can see that I think so now my audio is clear. Huh? Yeah, I'm audible. And so when we see these variations, the axial strain variations with the volume change in the sample, you can found that in a dense sand initially it will go in compression, but afterward it will go in expansion. While in a loose sand it will follow the same fashion from starting up to end. So these variations could be observed on the over concentrated and normal concentrated soil in a way. So this is due to the pre-consolidation pressure up to a extent. Now we come to the shear strength envelop and the pre-consolidation pressure. We have already discussed that the pre-consolidation pressure is one of the important aspects because on the basis of that we have stated the value of the negative and positive pore water pressure and many more things. So when we talk about the undrained shear strength curve rotate by 90 degree to form a shear strength envelope, there is a relationship between the SU and CU is influenced by the pre-consolidation pressure. And what is that interrelation? I will show you at this point of time. Give me a minute, I think so. Those interrelation I have mentioned somewhere, but that is not here. So I will bring that here for you. Okay, I think so. It will be visible now. Okay. So when this rotation takes place, these interrelations get developed. The relation we are talking about with the SU is twice the undrained cohesion, the behavior is influenced by the pre-consolidation pressure, and we would able to find the interrelation like Cu is equal to sigma 1 minus sigma 3 by 2, and where the Su is sigma 1 minus sigma 3. As stated above, SU is twice the undrained cohesion and its behavior is influenced by the pre-consolidation. Okay, so the practical, when we talk about the practical implications, the natural deposits often exhibit a dissipation zone due to drying of the topsoil layer. And talking about the engineering consideration, understanding the OC behavior is crucial in engineering projects, especially in the marine environment and the coastal area. So it need to be understood up to that extent. Afterward, again we take the quick summary of these sections. So the pre-consolidation pressure play a pivotal role in determining the soil behavior and the shear strength variations. Recognizing the influence of the pre-consolidation pressure help engineer to make informed discussions regarding the stability and the construction in the various geotechnical scenarios. Moving ahead, we take the triaxial testing of the soil behavior analysis, the pre-consolidation, shear strength, and the testing strength strategy. What are the strategy which we make during our calculations that we will taken into account from here, and some of the interrelations accordingly is also discussed for the sake of understanding of the concepts. So you will get a better idea of what we are discussing in this section. So the triaxial testing provides a valuable insight into the soil behavior under the different stress conditions. In these presentations, pre-consolidations, pressure, shear strength behavior, and the significance of the various triaxial tests in the geotechnical analysis is shown. So first of all, I will try to relate the value of the shear strength with the value of shear strength parameter like cohesion and phi. So over here in the left hand side, you can see the relation showing tau equal to c plus sigma tan phi, while similarly on the right hand side it is showing tau dash equal to c dash plus sigma dash tan phi dash. So you should understand, you need to understand like the value of c and c dash is not same and phi and phi dash is not same for the same soil and for the same test, because for the same soil only, because the drainage pattern is one of the thing which state the result for us. Okay, excuse me. Okay, I am taking some water in midway because I am feeling little problem in my throat, so excuse me for that. Okay, so the value of tau is equal to c plus sigma tan phi, and similarly tau dash is equal to c dash plus sigma dash tan phi. So what I am discussing over here, like the value of the c and c dash is not same, and similarly the value of sigma and sigma dash is also not same. And so the effective shear strength parameter and the total shear strength parameter will not be same. When we are discussing initially, we are talked about the direct stress, total stress approach and the effective stress approach. In the total stress approach, we have stated that the value of failure envelope developed during the different tests may not overlap with each other, but when we have considered the effective stress approach, over there we found that the failure envelope developed by any of the tests overlap each other, and hence the result is significant for us because we are stating the true result. Hence the value of effective stress parameter giving the value of shear strength, that is the effective shear strength, is more important for the geotechnical engineers as compared to the normal strength. Now, another aspects of the Mohr failure envelope is interrelating the diametric stress, that is sigma 1 minus sigma 3. So with the help of that we are able to find value of sigma 1, and from starting only from very early, from the very first class also I have showed you the failure envelope in today class as well. In the initial slides you have seen the more failure envelope. Over there I have stated that we know the value of sigma 3, and for the value of sigma 3 we calculate the value of sigma 1, and hence we are able to form the Mohr circle. We could able to find the radius, and we are able to find the radius, and ultimately, and okay, okay, and we are able to find the value of the radius of Mohr circle. Ultimately, after varying the value of the sigma 3, we find the another deviating stress, because you must understood that if the confining pressure is applied of 20 unit, the value of deviating stress will be maybe 10. But afterward, if we increase the value of sigma 3 from 20 to 25, the value of sigma d must change it from 10 to 9 or 10 to 8, or maybe in a other way. So you must understood the value get changed in this direction or in that direction. I am not mentioning right now in a true sense, but you should understood this point in a great manner, that with the help of specific 1 sigma 3 we get the 1 sigma 1. After that, for the second sigma 3 we get the second sigma 1. When we draw the circle and draw a tangent, we are able to form the Mohr failure envelope, as when we studied the total stress approach today only. Over there you found that the Mohr circle get formed of the same radius, and the tangent is parallel to the sigma axis. So that is formed by varying the value of sigma 3. But for all the variation of sigma 3, the sigma 1 is found to be same. But that is not the case we will found in every aspects when wherever we go. So you need to be crucial. You need to be understood those points. Now we talk about the pre-consolidation pressure and its implications. So first of all, we talk about the definition and its importance. So the pre-consolidation pressure represent a soil. So the pre-consolidation pressure represent the soil uh, his, soil historical maximum stress. It influences the current behavior, including the pore water pressure conditions. Talking about the positive pore water pressure, the soil stress is less than pre-consolidation pressure, resulting positive pore water pressure. Talking about the negative pore water pressure, soil stress is more than the pre-consolidation pressure, lead to the negative pore water pressure. And when we talk about the classification, the normal pre-consolidated exhibit a positive pore water pressure, while the over-consolidated display a negative pore water pressure. So these aspects need to be addressed. When we talked about the shear strength envelope and the pre-consolidation, and the undrained shear strength SU, and defined as twice the undrained cohesions influenced by the pre-consolidation pressure. Specifically, when we talk about the pre-consolidation pressure, in that case, this interrelation we are stating, and the poor water pressure classification NC material lead to the frictional behavior. Phi is not equal to 0 and C is equal to 0, while OC materials show a cohesive behavior where C is not equal to 0 and phi is equal to 0. And these aspects already stated earlier in a slide today only, where we have specifically discussed the NC and OC. We have discussed the definition, that what we mean by over-consolidated and normal consolidated. I have also shown you the two of the graph relating the strain and the derivative stress, representing the loose and dense soil and respectively for the normally consolidated and over consolidated soil as well. So those interrelations are also equally important. And when we talk about the practical implementation of this, the pre-consolidation pressure influences the shear strength envelope and the soil responses. When we talk about the unconsolidated undrained test, in UU test, the analyzing the unconsolidated undrained behavior suitable for saturated young offshore material, undrained total stress. When we talk about undrained total stress, UU test focuses on the total stress parameter like phi u and cu, not the phi u dash and cu dash. When we talk about the shear strength envelope, the UU responses forms a horizontal line on the tau sigma plane due to phi equal to 0 and the effective stress envelope by subtracting the pore water pressure and the effective stress envelope is often. Okay, so we will move ahead. When we talk about the juiciest test and the tri-excel testing strategy, the value of the unconfined shear strength UCS test reveals the negative pore water pressure due to lack of confinement and the when we talk about the comprehensive analysis, tri-excel test strategy CU provide a complete understanding of the soil behavior and interpolating the and exploring the CDCUU result help in establishing the range of soil parameters for the practical usage. Okay, give me a minute. I will recap these sections. Afterward, we will move ahead. Give me a minute. Okay, so I will recap this section for you. Sorry for interruption. There is a little bit problem in my throat, so I couldn't speak extensively. So I have to take water in mid between. Okay. So I will recap these sections. Afterward, we will move to next section, which is our last section for today discussion. So, in a tri-axial testing play a very crucial role in comprehending the soil behavior, including the pre-consolidation pressure effect and the shear strength responses. The proper interpretations of test result empowers the field engineers to make the informed discussion for the geotechnical projects, ensuring the stability and the safety in construction design. So it becomes very important to understood the cases, specifically when we talk about the loose and dense sand or the normally consolidated and over consolidated, which we discussed, and there is a representation also shown that how the variations takes place for the axial strain with the shear sigma 1 minus sigma 3 by 2, like the change in the shear stress. So those considerations are taken into account during the discussion. Moving ahead, now we will discuss the last sections for today, in which we will discuss the implementation of the material behavior and the test conditions. We have discussed about the triaxial test in a broader aspects. We have taken the UU test, CU test, and CD test. In the each of the test, what are the different factors, how the calculation of pore water pressure help us, how it is more beneficial than the other test like direct shear test and vane shear test is stated. Apart from that, how these test conditions result implicate the real field condition during the total stress and the effective stress approach, how the mover failure envelopes get overlapped during the mover failure envelope get overlapped during the calculation of the failure envelope in the effective stress while not in the total stress is also one of the aspects which we have understood. Now we will take this section as a in a discussion which will be going to be last section for today because I always try to take section by section so it will not get too much hectic for you and you may go whenever wherever if you are going across the this video afterwards as well you can go section by section so you will get a better understanding. So understanding the behavior of soil through the triaxial testing requires a careful consideration of test condition and results. In this presentation, we delve into the an example problem involving a saturated sand specimen subjected to triaxial testing, highlighting the significance of printing test results accurately. So the specimen characteristics, it is the problem, it is the statement which is discussed during the class as well. Over there is a tabular representation is also shown to you. I think you have gone across those lectures, so you will get some insights from there. So in that case, the saturated sand dimension has taken as 75 mm in length and 37.5 in dia. As we have discussed earlier as well, the length should be at least twice the dia for our analysis. So what we have discussed has been taken. When we talk about the consolidations condition, the cell pressure is applied at 75 kilonewton per meter square during the consolidation stage, that is the first stage, and implicit specimen consolidated under the cell pressure of 75 kilonewton per meter square. The cell pressure afterwards we ordered, we apply the sigma the Deviatric stress, we find the value of sigma 1. Similarly, we increase the pressure up to the 550 kilonewton for the cell pressure only. And the test type we performed over here is the untrained condition like UU test and the some of the important interrelations to find the value of strain delta L by L and E final. Basically, you are aware, little bit aware about the different corrections which we are talking about. So the delta L is the decrease in the sample length during the shearing and proving ring readings indicate the value of the deviatric stress. Basically, the stress which is applied in the axial direction. The proving ring stated what much stresses we are applying during those conditions and so the axial strain. The pore water pressure is monitored during the test because we are mostly concerned about getting the effective stress parameter rather than the total stress parameter. So the pore water pressure needed to be monitored during the test. And this test setup allow those measurement for us. Okay. So the specimen has a shearing progress, proving rings reading, and the axial strain changes. And the proving ring reading, the top value reflect the shear stress at the value of with the help of deviatric stress. The axial strain, that is delta L by L, depended by epsilon A, and ultimately we able to get the value of volumetric strain. And we know that the condition is the drainage is not allowed during the entire process, so the initial volume remain as equal as the final volume because there is a no valve is allowed to the water to flow out, so the volume remains same during the complete process. And when we talk about the pore water pressure, the variations correlates the volume changes, and there is the interrelations which is coming in the next slide, where you get the clear idea about what we are discussing. And I think you must be aware if you have gone through the videos of sir. So the volume changes like drain test, and drain test have the constant initial and final volumes. And when we talk about the pore water pressure measurement variations, reflect the volume changes due to the undrained condition. And if the condition is drained, so no pore water pressure get developed because all water get dissipated from there only. And the interrelation which I am talking about, interrelating the value of a final, basically A1 is nothing but A final, that is A final is 1 minus delta L by L, that is A final is equal to A initial by 1 minus epsilon A. This is the correction which we need to apply on the area. Otherwise the stresses which we are getting is not the true value. Afterwards we get the stresses by dividing this A1, dividing the value of load which we are applying, at which the failure takes place, dividing by this area, because during the result the change in length takes place, due to which the strains get developed, that need to be compensated during our calculation. Otherwise our result will not reflect the true field conditions, which will actually takes place in a field. Okay, this is the same image implementing the same concepts which I have discussed just earlier. And the OC and NC, basically over concentrated and normal concentrated soils, are these two. So those aspects I have earlier discussed today only in some slide earlier. Now, shear stress behavior. The proving ring which read the value of tau for us, that is the shear stress for us, have minor changes in the shear stress due to the variation in sigma d, and the undrained test maintain the initial and final volumes, and the changes align with the volume adjustment during the test. Now I will recap these sections for you. Afterward I will take a small problem, and no, one more section is there. Okay, okay, one more section is there. I will take 5 more minutes today before ending our my session. Okay. So the intercepting the triaxial test result demands a meticulous attention to detail by recognizing the clues like volume, equivalence, and the pore water pressure, the variations. Engineers can accurately diagnose the soil behavior. So that's we are more interested in. And the critical connections between the test conditions are also evolved. Okay, now we will discuss decoding the triaxial testing, understanding the material behavior. Material behavior is understood, has been stated several times, but we will take this section about those aspects in little more concern. So the triaxial testing is crucial tool in the geotechnical engineers to understand the soil behavior under the different conditions. In this presentation, a case study has been stated to inside that problem. So shearing and pore water pressure. Decreasing pore water pressure. Notable observation is found that the pore water pressure decreases as shearing progress, and the unexpected behavior in a undrained test, usually water pressure rise, has been found. When we talk about the behavior of material, it is recognized the significance of decreasing pore water pressure has been observed. Okay. Now, the understanding the volume changes, initial and for final volume, initial and final volume equivalence for undrained test. Initial and final volumes are same as it has been shown earlier, just in the previous section. Vi equal to Vfi has been shown to you. And when we talk about the volume correlation, the correction factor we have used, like AF equal to A by 1 minus delta L by L. Similarly, the volume is correction is also required, but as the volume remains same, so the change in volume is zero, so the volume correction doesn't require at those places. But wherever it is needed, it is written as V equal to V1 plus minus epsilon V by 1 minus epsilon L. So the proving ring and the shear stress, the proving ring reading represent the shear stress sigma d, that is the deviating stress that is going to occur over there. There. The deviating stress is nothing but sigma 1 dash minus sigma 3 dash, that is derived from proving ring reading and the application of area correction. The area correction factors include those terms. We applied the load at which the failure takes place by that corrected area, and we found the stress at which the failure takes place. And hence the deviating stress afterward, we are able to get the value of sigma 1 dash by subtract by adding the value of sigma 3 dash in the sigma deviating stress. Okay. Now, the differentiating between the NC and OC could be represented with the help of this, because we could form a graph, and with the help of graph we could state that how this variation takes place. Either the normally consolidated soil exhibit this, or the over consolidated. Hence, our answer get stated. Now, we talk about the importance of Mohr circle at field here. So verifying test completion. The plotting result to determine if the peak failure point was achieved. And when we talk about the quality control, ensuring the components of test through Mohr circle visualization. The role of interpolation is equally important, as interpolation involves the understanding of trends and behavior which soil is following, and often the test prompt more questions than the answer required to expect the analysis. Now, at the on the recap of this section, the triaxial test unveils the vital insights into the soil behavior, but effective interpretation is paramount important, and we need to take care of that. The several case study also demonstrates that the triaxial test is irreplaceable, and it is going developed with the time by use of the modern technology in it. Now, there is an example problem stated over here, in which we have to calculate the total strength parameter as well as the effective strength parameter. And over there, you could find that the value of sigma 3f is given, and on the basis of that, the value of sigma 1f and is found, and so the value of cohesion. So I have gone through the question discussion earlier as well during in the second session. So I think you could solve those problems. So now I am ending my session with the one of the important understanding, that what we have understood from the today lesson is, we have understood the triaxial test, we understood the different aspects of triaxial test like UU, CU and CD test. We have also gone through the UCS test of a extent in which we find the several correlation and corrections value. Afterward, I will want to you to solve some problems related to today discussions, and the what is the value of shear strength, the procedure of triaxial test, the equipment used in the triaxial test. Try to write in your own way, own words, own understanding, so you will be better in answer writing as well at any examinations. And if it is possible, perform this test at your institute, and you will take some problems from the today discuss. In a coming session, I will solve some more problems from the this topic only. Today the time doesn't permit. I have to go little faster as well at the end. So I haven't taken that much question. So, and these presentation will be shared. And these are the references which I have used during the preparing this presentation. So you must go across these problems. Try to write by your in your own word. It will help you. It will enhance your understanding. It will lead to your increase in your knowledge base. So, and this is my humble request. So please go across those problems. And these are the references. Apart from these references, the many references are mentioned in a course content as well. You can go across those books, or whichever you have access to, and over there the problems are there on this given topic. You can solve this. If any doubt is there, you can ask me in a upcoming session. I will try to state the solution for those problems. So with this, I will end the today discussions. I think this session will be helpful for you because it is already passes the session time. So I need to close the session because some of you might have to join another session. So thank you for joining. Thank you for being with me for this time. I hope this session will help you up to extent. So see you in the next session on the next Saturday at 3 o'clock. Wish you a very happy weekend. Okay, thank you.